All right, so we make sure you bring it back, please. I see the bathroom hands. Where are notes? Up first, we're in 2.01, and so yesterday, right? You guys took your Unit 1 test. We are. Again, I gotta have the talking stop. We are shifting into Unit 2, and so not gone, but we're moving away from equations and expressions, and we're moving into slope and lines and graphs. Just grab another one. You're good. Slopes, lines, and graphs. Take a question. So again, go to the last page in your packet, and that should be your notes. Tear it off. I need people to listen to my instructions. (2.01) Calculating slope graphically and algebraically. When we talk about slope, it is a number used to indicate the steepness of a line. Steepness. And so, the farther away from 0 a slope is, the steeper it is. Doesn't matter if it's positive or negative. The farther from 0, the steeper it is. We can also use this to indicate whether a function is increasing or decreasing. And so slope is a number used to indicate the steepness of a line. It also is used to indicate whether a function is increasing or decreasing. Slope can be positive, negative, 0, or undefined. For us right now, those are all 4 options. We are not going to see anything outside the realm of these 4. And so I actually want us to really zoom in on the types of slope. Now, you have this in front of you. When we see a positive slope, the way that we know it is positive is because, as it says below it, what, Tay? Louder. Increasing from left to right. And so as we go left to right, that line literally goes up. For negative, how do we know that it's negative? How do we know that it's negative? What does it say right underneath, Michael? Decreasing from left to right. And so as we go, again, from left to right, notice it's always from left to right. The line just goes down. From here, there are 2 special cases, 0 and undefined. 0 is a horizontal line, right? It's a nice, flat, perfectly horizontal line. Whereas undefined, its counterpart, is a vertical line that is straight up and down. We'll see 0 and undefined a little bit later in the unit. We are going to focus heavily with positive and negative today. When you are asked to name why something is positive or why something is negative, these are the reasonings I expect you to use. When asked, those are the reasonings I expect you to use. Flip your notes, please. All right, so slope graphically. Now, we write this differently based on how we see this. And so graphically is a little bit different than what we're going to see for algebraically. For graphically, we're going to have m. M is what we use for slope, m. So the equation y equals mx plus b is slope intercept that we'll see a little bit later. For now, we're going to start to build the parts of it. And so it's slope. M is equal to, graphically, rise over run, which we also call little triangle y over little triangle x. Now, these little triangles have a name. Raise your hand. Do we know the name of these, Monty?
Is the triangles change? Change in y over change in x?
So the triangles mean change. And so this is, as Monty just said, change in y over change in x. Specifically, these triangles are Greek letters. This is delta, Yes, somebody asked earlier, like the plane, if that helps you remember it, sure. Delta, specifically though, it's used for, as Mani said, change in. And so we have delta y over delta x, change in y over change in x. Now, I am going to, and I already have today, said this like 20 million times to the point where like I need to like make tea because I can feel my voice starting to go. Slope is always y over x. Slope is always y over x. Slope is always what, Jaden? What is it? Y over x. I need everyone to be on the same page that this is y over x. It is going to be the number one mistake we make. I am ready for us to make that error. However, I want to try and make it as few times as possible. And so, let's see this in action. If I come to a problem like example 1, and I need to know the slope. 1, I don't have any points marked. And so the first thing I have to do is actually identify 2 points that I can work with. I'm going to choose this point right here, and we'll do this point right here. Now, for the sake of working with this graphically, I'm actually not going to label these because we're going to find there's a way of doing this without knowing necessarily what the points exactly are. What I want to be clear of is how I'm choosing my points. The points I select should fall cleanly on a crosshatch of the grid. And so, for example, this right here, trying to use this, that is what I would consider a bad point. That is not something we want to use. If we were to try and assign values to that or count in the way that we're about to for the other 2 points, it would be really difficult because you all of a sudden have like half numbers, decimals, you have to guess. Don't make it that difficult for yourself. Choose easy points. And so, once we have this, I'm going to draw in a right triangle. I'm going to choose to go up until I would get to that second point, and then I go to the right until I actually hit that point. And so there's my right triangle. Now, this is oftentimes referred to as slope triangles, and so if you see, I don't know, a question on like an IA that refers to slope triangles, this is what they mean. Where we go from here is truly checking out, okay, well then what is the change in y and what is the change in x? So I'm going to use orange just to be super clear up here for my change in y. I'm going to use green for change in x. And so when we find these, it is just counting. That's all this is. And so I'm going to count how many I went up.
We can't see this, right? You know that? You know we can't see like the lines on our paper?
Yes, that's why I'm being super clear about it up here in color coding. 1, 2. Okay, so I moved 2 up. Now, on a coordinate grid, raise your hand, please. Up is what kind of a direction? Sage. Alex? There's one. Positive. Thank you. Up is a positive direction. Bring it back, please. And so, because up is positive, I actually don't do anything to the number. This is just 2. It's positive 2. For change in x, I'm going to do the same thing. 1, 2, 3. Again, right is also a positive direction. And so this is just 3. And so now that I have these 2 values set up, all that's really left is for me to actually just substitute them in to my fraction. And so I'm going to have slope is change in y over change in x, which means, right, that slope here is, raise your hand, what as a fraction? Monty. 2 over 3. Please, please, please. 2 over 3. It is not 3 over 2. Y needs to be on top. Any questions about finding slope graphically? Alex?
Isn't the slope equation y equals mx plus b?
No, that is slope intercept. So again, as I had said previously, we are going to get to that, but we're building the parts of it first. Answer our question.
Yeah, it's like about the calculator, because isn't there a way that you can graph? Like,
Yes, I'm not worried about that right now. I'm worried about us being able to do this right now. Other questions? All right. Slide over. Example 2. We're gonna just go right on through for notes. We're now going to look at this algebraically. Now, algebraically, things are a little bit different. I am quite literally just not given a graph. That's why we say graphically versus algebraically. Instead, I'm going to be given 2 coordinate points, which we can see right down below in example 2, right? And so, a few things. First, in order to actually calculate slope algebraically, let me be very clear, you need 2 points. Until you get to calculus, you can't do this without 2 points. And so we need 2 points, right? And remember that points are always x comma y. And the reason for this is slope algebraically is y2 minus y1 over x2 minus x1. And so it's one y value minus the other y value, that same x value or coordinating x value minus the other x value. The most important part of this is that you are lining up points vertically. And so x2, y2, that should be from one single coordinate point. x1, y1, that should be from another single coordinate point. When we see examples like this, the first thing I need to see on papers, annotations. I know that this is x1, this is y1, this is x2, and that's y2. That is always going to be the first thing I want to come around and see on papers. Because then it's actually just a substitution game. If I know what each of these values are, I can just substitute them directly in to the fraction that we wrote. And so m is going to be equal to, okay, y2, negative 6, minus y1, 10, over x2, 5, minus x1, negative 3. Be really careful with parentheses, please. I'll move this up. Parentheses can make or break us setting up slope because, everybody, a double negative is really a what? Positive. And so I'm going to have negative 16 over 5 plus 3. Give me negative 16 over 8. And so raise your hand. Negative 16 divided by 8 is really what number? Zahara, louder. Negative 2. And so our slope is negative 2. Any questions right now? Okay, then we're going to skip the key takeaway for now because I actually just want to give you more time to practice. And so at this point, fold your notes, get them glued into your notebook. You've got 1 minute. Go.